Assalamualaikum and a very good day to you. My name is Muhammad LUKMAN NURHAKIM bin DAHAM and my metric number is B0918100150. Today I want to represent to you about my Bachelor degree project 2, which is the title is Design and Fabrication of Marine Boat Propeller Hub Mold for Investment Casting. And my supervisor is TS Muhammad Shafiq bin Jubali and co-supervisor TS Zulkarnain bin Marjum. Okay, let me start with the introduction. So, what is boat hub propeller? Which part it is, and what is the function of the hub? So, the hub role is to hold the propeller hub blade, and the hub is bolted the flash end of the boat tail, and the propeller blade are bolted to the hub. So the hub role is to hold the propeller blade. That means the hub propeller is the one important part in boat. Investment casting has been extensively used to produce significant global industrial process of the best quality product. Thus, ongoing enhancement in quality of product surface roughness are essential to sustain and competitive edge in the casting industry. Material, method, and mold of this component as the process generate effectiveness. In this project, two different machining strategies used with the same parameter to produce the mold. Then we continue to the problem statement. Number one is the time. So in the making of the boat propeller hub, it takes a longer time to complete the part due to its complex shape. And then cost. The cost of the making is this part also the highest cost. It is because the longer time taken, the higher cost will be paid. Next, complex part. Due to the complex part, it will face some problem and will have difficulty in created cam process. Hard to get the suitable accurate parameter for the best surface roughness. Lastly, hard to produce. Due to the complex part, it requires skilled worker to produce it. So, we move to the most important thing in this project, which is objective. So, the objective number one is to fabricate the propeller hub blade from mold investment casting method. Second, to study sweeping and isoparametric machining strategy to optimize the marine boat hub propeller blade mold. Lastly, using CNC high-speed machining and CATIA version 5 software simulation for the best mold surface roughness by using same parameter. Okay, now scope of the research. Number one, fabricate and design the propeller hub blade mold for investment casting. Second, sweeping and isoparametric machining strategy. After successfully fabricate the mold need to do a surface roughness testing. And lastly, simulation using CATIA version 5 software. Material. In fabricate this mold, aluminium is selected material because it has low density, is non-toxic, has a high thermal conductivity, have excellent corrosion resistance, and can be easily cast, machining, and formed. The series number for this aluminium is AA6061. Investment casting. In investment casting, they have 4 steps for making this product. Number one is pattern 3, shell making. and investment casting. In this project, molds are fabricated to produce the wax pattern in the step number 1, which is pattern 3. Pattern 3 is the pattern creation. Wax designs are molded into a metal die and created as a single piece. Core can be utilized to create any internal pattern characteristic. To produce a tree-like assembly, several of these patterns are attached to the central wax getting system like sprue, runner, and riser. The getting system creates pathway for the molten metal to pass through on the way to the mold cavity. CNC high-speed milling machines are selected to fabricate the mold with good reliability potential. This machine can produce the good surface roughness of the mold by apply the machine strategy. Now, what is machining strategy? The objective of the study presented here was to analyze the different machining strategy of sweeping and isoparametry. The machining quality was assessed by comparing surface roughness and dimensional control parameter. These assumptions are the main focus of the application of machining strategies. Done with the literature review. Now we move to the methodology. Okay, project flow. So in this project, all the design or all part are designed in the CATIA version 5 software. To perform the fabricate of this mold, isoparametric and sweeping machining strategy are applied in this making of this mold. In CATIA version 5, computer-aided manufacturing simulation are used to see how the software produces the mold. In this process, isoparametric and sweeping machining strategy are applied. After finish the scan, generate the NC code to transfer to the CNC milling. Then, after finish the design and simulation the mold, conventional milling machines are used to produce squaring from raw material. This process is to make stock preparation before running in CNC machine. Then, need to transfer the NC code to the controller. Make sure tool used are reloaded. Then set the datum of the mold, which is 0080 of the mold. The NC code need to do checking by doing the dry run. It make it easier to find any error or accident in the machine. After all are done and saved, run the machine and monitor the machine until it finished. After all parts are finished, assembly part of the mold. Lastly, measure surface roughness on female and male mold. Compare the result between two machining strategies with the same parameter. Now we move to the selected design. From the design created, design number 3, which is the right side, was the most suitable, most on the design for manufacturing or design for manufacturability, which is DFM. It is because the optimization of machining ability or part design created it cheaper and more easily. Compared to design number 1, the mold design its size is quite large for the propeller hub blade. This will require a high cost to buy or provide raw material compared to design number 3, which is smaller and very suitable for the size of the hub. Besides, in the design of mold number 1, there are some mistakes have been encountered in the hole of pouring method wax and there is no airflow for this mold. The boring hole has been designed at the top of the mold. This will cause difficulty in separating between mold and can cause crack on the part of the pattern produced. In addition, the flow of the melted wax also suffer from problem because the mold does not have good ventilation. Then for design number 2, it's not selected because they have limitation in machining using CNC machining. The shape of the top and bottom insert was square and it will produce edge inside the slot that is very possible to produce by CNC machine. In the design tree, the problem was fixed by producing the two insert to be cylinder shape and have filler on each edge. This will facilitate the process in machining this mold and it can be easy to fit to the insert between the both sides of the mold. The design mold involves efficiently design or engineering an object, generally during the product's design stage, when it is easier and less expensive to do so to reduce manufacturing costs. This allows manufacturing to identify and prevent mistake discrepancies. Now we move to machining strategy of this project. For this male mold, isoparametric machining are applied to perform the machining operation. Isoparametric machining command was capable to give both 3 and 5 axis part movement. It was definitely depending on how the program created or customized. For this research, there were 3 major settings that been set to ensure the 5 axis shape program can be cut using 3 axis program. All settings took place in the first page of the isoparametric interface window, or namely cutting strategy window. The first setting was the toolpath style or the cutting direction style. In this option, we were given two choices, zigzag and one-way cut. Zigzag strategy was chosen for this option. The main reason one-way cutting selected was to avoid high vibration and centering during actual cutting. The second setting was the most important setting that control the number of the toolpath that going to be produced. The option used for this command was scallop height and uh, the value set was 0.01 mm. The value was set the smallest and the finest allowable value. The final setting need to be done was the setting on the tool position. This command usually used to solve the shape of chamfering, filler, radius, and complex contouring. The main rule that has been set in order to perform the process by using ball nose tool. The movement generated from this command is z direction. It can show in the toolpath style. That's why we need to use the ball mill tool to avoid any force cutting at the approach level machining, which can cause hard chittering and the worst case broken the cutting tool. Now we move to the machining strategy number 2, which is sweeping machining that apply to the female mold. Sweeping strategy were adopted to do the finishing process. Sweeping is a semi-finishing and finishing operation that is used after part has been rough machined and the whole part. The tool part are executed in vertical and parallel plane. The first setting was toolpath style, cutting direction style. In this option, we were Given two choice, zigzag and one way cut. Zigzag strategy was chosen from this option. The second setting is the scallop hub. It's same with the isoparametric value, which is 0.01. Sweeping method can generate high quality hydra, hedral meshes for swept volume. The procedure used in most sweeping method first classify the surface of the input swept volume into source surface, target surface, and link surface, where the source and target surface are called cap surface. Then the source surface is meshed with the quadrilateral mesh and link surface are uh, mesh with a structure quadrilateral mesh. Finally, the swept is generated in layer by layer style along swept direction. According to the number of source surface, target surface sweeping operation can classify into the most easiest, which are all suitable for generated sweeping operation. Now we show the result of the surface roughness with the same parameter setting for the sweeping and isoparametric, the feed rate, and all machine parameter are the same. Based on the graph uh, shown, the result of the surface roughness of both mold with a different machining strategy show the average surface roughness were recorded, and the value show that the surface roughness value does not vary using the same parameter. This just show that with the right value parameter such as cutting speed, feed rate, and depth of cut, the surface roughness can be decreased. It happened to the sweeping machine strategy that surface roughness result much better using the parameter than isoparametric machining strategy. It is because the machining parameter need to be combined with the machining properly and need to further study to get the best surface roughness result. Even the difference of the surface roughness of both mold can be seen by normal eyes or naked eyes. So in conclusion, the propeller hub blade mold for mold investing casting method were produced successfully. And second, be able to produce cam simulation by using isoparametric and sweeping machining strategy in CATIA Vision 5 software. Lastly, successfully proved that sweeping machine strategy is the best surface roughness in this project by using same parameter with isoparametric machining strategy. Lastly, the recommendation of this project is to create the spatial jig and feature to open top and bottom insert of the mold. It facing difficulties to open that insert when the wax is applied to the mold. This problem that found after do testing the mold with pouring method wax to the mold. I hope in the future this paper can act as a reference for the further study of this project. I think that's all from me. Thank you and Assalamualaikum.